Hey guys, so this video is about volume of a cone, and a cone is an object that looks like this. I think of like a orange road cone or something like that. And we're gonna find the volume, which means if I was to fill this cone up, I'd be calculating its volume. So I'm gonna write fill it up. And so we know we can fill it up with sand, we can fill it up with rocks, we can fill it up with water, we can fill it up with lots of different things, and we want to know how much of whatever we put in there fits in there. And so the way we figure this out is we use a formula. I mean, that's kind of what we do for all of our volume problems is we try and find a formula. But the formula has to come from somewhere. And so where does the volume of a cone come from? And to be honest, where it comes from is knowing what we know about volume of a cylinder. Volume of a cylinder relates to this directly. And let me show you something here. Okay. Let's imagine this cone is actually inside of a cylinder, like perfectly fits in a cylinder in such a way that the radius of the cylinder and the radius of the cone are equal to each other. So that you have that nice cylinder and then you just slip the cone right in. Well, if that's the case, we know that volume-wise, the cylinder has a bigger volume. There's all this extra space. So if I was asking you like, okay, I have this cylinder, and then I have this cone. Which one's going to have more volume? Well, the cylinder has more volume. You can see the extra space in here, but the question is how much more volume? That's the big question. So I have another video posted on here about that where it's not my video, it's made by somebody else, where they took a cylinder and a cone, and they fill up the cone with water and they dump it in the cylinder. And you have to watch the video to see how many dumps does it take to get that cylinder full. And it ends up 3 of these fit into one of those cylinders. It's 3 times smaller in terms of volume. So our volume formula comes from the cylinder. Remember, the cylinder formula is pi r squared times height. Area of the base is a circle, so area of the circle times the height. And so what we do for a cone is we say, well, it's just like 1/3 of that in size. So we literally just put a 1/3 out in front, basically dividing it into 3, dividing it by 3. So 1/3 pi r squared height. And if you didn't watch the video with the cone and the water, I think you should go back and watch it, because when you see it, you're like, oh yeah, that makes sense. It just kind of clicks everything together. So that's our formula. We're going to memorize it for the most part, 1/3 pi r squared height, and we're going to use it. So let's try a problem. Let's do an example here. And for our example, let's say we have a cone going in this direction, just to make it different. And this cone measures across in distance, we'll say 4 feet. So it's a larger cone. And then from top to bottom, this thing has a measurement of 3 feet. And I want to know if I filled this cone up with water, how much water would fit in it. So really, I just want to know the volume of this cone. What's the volume? So I'm going to write down my formula, 1/3 pi r squared height. But then I'm going to take that formula and have to basically change the variables out with numbers. So volume equals 1/3 pi times something squared times height, so times something. I'm going to make some blanks. And we have to figure out what's the radius and what's the height, and kind of insert those into our equation. So let's look at this problem. The radius would be the distance from the center of the circle down. That's our radius. So if this whole thing has a distance of 3, that must be our diameter, 3 feet. The radius in this case is going to be 1.5 feet, half of that. So for r squared, I'm going to be putting 1.5 here. And then the height of my cone, you know, it's kind of deceiving. I know that this thing is 4 feet wide, but technically if I turn my cone and looked at it this way, that 4 feet is its height. So when I talk about height, I'm going to be talking about that 4-foot number. So I'm actually going to label that on here, equals height, so I don't forget. And then I'm going to put a 4 in here for the h, for the variable for height. And then I got to clean this up and solve. So volume equals 1/3 pi times 1.5 squared. Okay, so be really careful when you're doing this. That's not 1.5 times 2. Think about what 1.5 squared means. That means 1.5 times 1.5, multiplying them together. So that is 2.25. So I'm going to be putting 2.25 times 4 here. All right, so volume equals, let's go to the next step. Let's do 2.25 times 4. We get, oh, a nice number, 9. So we get 1/3 pi times 9. Okay, well then, let's think about this 1/3 times 9. Really, what that really means is I have volume equals 1 times 9 divided by 3. I mean, that's what that really is. 1 times 9 divided by 3. Well, that's 9/3 pi. So 9 divided by 3, well, I don't need a calculator for that. That's 3. So volume equals 3 pi. And if I didn't have a calculator, I would for sure be stopped at this step, 3 pi. But because I have a calculator, and I know pi is that decimal that goes forever, I'm going to change this to an about equal sign. And I'm going to multiply 3 times 3.14, and I'm going to figure out what that is. About 9.42. So 9.42. And the units on this thing, remember we were measuring everything in feet, so this is definitely a feet answer. And it's volume, and this is a three-dimensional 3D object. We're talking about filling up a 3D object, so that means I'm going to have cubic units. I'm going to have to the third power units because it's 3D. So final answer here is 9.42 cubic feet, and that's volume of a cone. It's really the big idea in this video is just making sure you understand what's the formula, how do I, put the numbers in correctly, kind of show my work, and remember when you get down to this part with the fraction, just to kind of go slowly, make sure you do, 1 times 9 divided by 3, make sure you do it in the right order, and if you can do that, you're probably good to go. You probably can do this just fine. All right, hope that helps. Thanks. Bye.